Jumping into my circle worksheet, I got 6 really good circle problems here. They're going to help us reinforce, review all the roles we're going to have to know for circles, geometry, etc. So starting with number 20 here, I see that we have a circle with center C. So we go ahead and draw this. And I label this, we have center C. But they also say that this has coordinates HK. So maybe off to the side, we have HK. And they tell us that point A and B lie in the circle. So before I rush to kind of draw them, I always like orientating it correctly. So like if it's in the negative quadrant, if it's in a positive quadrant, I want to see that first. So they say point A has coordinates. So look, this is our X, this is our Y. Starting from H, starting from our center, let's get a different color, we move 1 in the X and square root of 102 in the Y, both positive. So I throw A up here. And again, I can start with drawing my radius, but ultimately they give us an X and a Y, don't they? They tell me that my X to this triangle is going to be 1, and they tell me the Y to this triangle is going to be square root of 102. Now again, that's because I start at HK, H plus 1 in the X, so it's an extra 1, and starting at K plus square root of 102 in the Y. So here's my 2 legs of my triangle. You should be thinking Pythagorean's theorem. With Pythagorean's theorem, I can solve for my radius here. That's going to be our a squared plus b squared equals our c squared, or 1 squared plus square root of 102 squared is equal to c squared. That's just going to be 1 plus 102 equals c squared, or finally 103 equals c squared. Take the square root of both sides, and we've solved for our hypotenuse. This is going to be square root of 103. And let's go ahead and get rid of all this. So we've already made a lot of progress. We have our radius. Let's see what direction they take us next, right? Because I think we're only halfway there. They say, and angle ACB. So remember, there's that point B too. So to get angle ACB, it's going to be starting at A to angle C. We want to make a right angle to get to angle B. So I'm thinking it's going to be something kind of like this. That looks like a right angle. And this is going to be B over here. Ultimately solving for, they want this length from here to here, that AB there. But we should always, especially in these circle problems, but in geometry in general, always remember your triangle rules. So this AC is a radius, square root of 103. Anytime I have a center to end point on a circle, it's a radius. So this, I'm going to go ahead and get rid of this HK. I don't think we need it anymore. This is also going to be a radius, square root of 103. This should trigger another thing we're supposed to remember. It's also on our equation sheet, but we still have to remember it, are special right triangles. This is a 45, 45, 90. The reason why I know it's isosceles is because these 2 legs are the same, which means that these 2 angles have to be the same. So if we remember, or we can go check our equation sheet, our 45, 45, 90 triangle is going to be x, x, and x square root of 2. Or square root of 103, square root of 103, square root of 103 times the square root of 2. Again, double check your equation sheet if you want to look at this real quick. When you multiply radicals, you're allowed to just go underneath the radical with both of your numbers. So square root of 103 times 2, or square root of 206. So again, with this one, you just want to stay organized. Try to draw it as best you can on your scratch paper. Remember all of your roles here, and we should be getting A for this hypotenuse length here. Jumping into number 31, I see that we have our center HK. We have these 2 points, and all they tell us is our radius is 10. So right off the bat, I want to think, where can I draw the most effective radius? And again, a radius is from our center to an endpoint on the circle. Well, I should draw to here, because with that line, if I know this is 10, I can try to figure out some sort of way to get from this coordinate to my other coordinate to get maybe like an X or a Y here. So I know this total distance here is going to be 16. And if these are both radiuses, then this has to be a center, right? This has to be symmetrical. We could bisect this down the middle. My distance from 4 to my H and from H to my 20 should be equal to each other. So if I say, okay, that means this value here, if I draw a line down the middle, this line here should be 8, and this line here should be 8. So we have another right triangle. A secret to a lot of these circle problems is drawing a right triangle. So if I know this side is 8, this side is 10, and we're solving for this k value, our y value, right? In our x-axis, or in our top right quadrant, our x distance is to the right, our y distance is up. This k is going to represent this height of our triangle. So I could do Pythagorean's theorem. I could do k squared plus 8 squared is equal to 10 squared, or I could also remember our basic special triangles, and that is the 3, 4, 5. Remember that our 3, 4, 5, all you have to do is multiply all your sides by the same thing, and it's going to be just a variant of our 3, 4, 5. So if I recognize that some of these are multiples of 5s and 4s, like if I multiply everything here by 2 and I get 6, 8, and 10, that's also a 3, 4, 5 triangle. So I actually know right off the bat, this k is going to be 6 here. Not too bad. Jumping into number 36, I see that we have point P as our center, and then want to solve for x. Not much info, but we can recognize what type of shape this is. I see 1, 2, 3, 4 sides. This is a quadrilateral. We know with all quadrilaterals, the internal degrees must add up to 360. So I get my angles. I say, okay, we have angle A plus angle P plus a 20 and a 20, so plus 40. And this should add up to 360 degrees. And I get rid of all that. And I look for any other special angles I might have here. And I see that anytime I can draw a circle around two angles, P plus X should also add up to 360 degrees. And finally, this is going to be a little special one. When I see that this X here is off of my center, and I see this A over here is off of an endpoint, there is going to be a relationship between these two. Just try to think which one looks smaller. A is going to equal 1/2 of X. So that's it. Here's our three equations. We have three variables. We should be able to solve for everything. Let's start with, we know that 360 is equal to P plus X. So if I kind of combine these two, I could say A plus P plus 40 is equal to P plus X. I see another equation with A and X, so if I get rid of my P's, that's perfect. Minus P from both sides, I get A plus 40 is equal to X, and I want to try to use this as well. 1/2 X for A plus 40 is equal to X. I can times everything by 2 just to get rid of my fractions, or I could subtract 1/2 X from both sides. We can do that. 40 is equal to 1/2 X, or X is going to be equal to 80 here. Not too bad. Pay attention to all your shapes, your internal angles, and being able to form especially this equation here. Looking at another number 36, I see we have a radius of 10. And we have an arc length, AB, that's between 5 and 6. So let's choose something easy like 5.5. So we want to remember the relationship between arc length and angles, and let's kind of map that out. So I know X is in degrees, and I know it is a part of our total degrees of a circle, that is 360. And this has to be equal to that angle's arc length. Again, we made it 5.5 because it's between 5 and 6. And the total arc length of our circle, which is going to be our circumference, or 2 pi r. In this case, that's going to be 10. And to solve for this X, again, we're just going to use Desmos to do our algebra for us. Let me type this in. I have X divided by 360 is equal to 5.5 divided by 2 pi times 10. And I zoom out, I look for my solution here, and it looks like it's going to be about 31.5. So let's go ahead and minimize this. So we get X is equal to 31.5. So again, Desmos will do our algebra for us. We set this up because the angle and the arc length that is made by that angle, compared to both of their totals, 360 and the total circumference, they're going to be equal to each other. Now they wanted an integer here. It's nice that we chose our center, the 5.5, because technically I could answer 32. I could answer 31. If you actually wanted all of your possible answers, you'd have to plug in a 5 for this and a 6. And I think you're going to get all the way down to like 28 up to 34 are all going to work here. But that's it. Jumping into another good circle problem here. I see that we have center O, and we have the measure of angle AOB. So this is pi over a radians. So we're ultimately solving for an angle here. But let's map out our sides first. Just like the first two problems, we have point A. This is my x distance. This is my y distance. So I know this is 1, and I know this is square root of 3. So again, you don't need to know the unit circle. We do need to know our sine, cosine, and tangent rules, SOHCAHTOA. So I see an angle, I see an opposite, and I see an adjacent. So I know I'm dealing with tangent, and let's just call that angle x. So tangent of x is going to be equal to 1 over square root of 3, or opposite over adjacent. And again, this is a different one. We are trying to solve for this angle, this x. So to get rid of tan, this is all stuff you can do in Desmos, but you do have to remember to do this. You have to do the inverse of tan. So if I take inverse of tan, that's going to get rid of both my tangents. It's going to leave me with x, but I have to take the inverse of tan of my other side too. So if I take the inverse tan of 1 over square root of 3, it's going to give me my angle. So let's pull up Desmos here. I type in, first we have to find where the inverse of tan is. Just go down to your functions. It's going to be right here. Inverse tan of 1 divided by square root of 3. And we're going to get this decimal here. Now remember, do they want radians? Do they want degrees? It's very important that we make sure we're on the right one. Radians, you're always going to get a weird decimal. Degrees, it would have given me something nice like 30 degrees. But again, we want this in radians. So remember what they asked in the question. Let me make sure you can see it. I'll hide this for, actually I can kind of slide this over. So they're saying AOB is pi over a radians. Well, we know AOB is 0.5235 radians. So again, we let Desmos do our algebra for us. Pi divided by, we're solving for A, but we make it X in Desmos because that's how it solves for stuff. And we set it equal to 0.52359. That should be enough decimals. And again, it does it for me. I zoom in on this point here, and it looks like my X or my A is going to be 6 here. Not too bad. Jumping into our final circle problem here, a really excellent one. We have a circle with center G. Let's draw it. And our center here. And again, just like the first one, we don't want to draw our points M and N right away. Let's get more info. Line MH and NH are tangent to the circle at points M and N. So again, let's go over our tangent rules here. If I draw a random line that intersects our circle right here, is going to be a single intersection point. Let's change the color here. Let's call this M. So there's a couple rules about tangents. Again, it's only going to intersect our circle once, and it's going to form a 90 with that radius from center to point M. So we have M. We know M connects to H, but then we also know NH is also tangent. So just for the sake of trying to draw this, before I do H, let's also draw N. So I'll try to draw a second tangent line here, maybe like right there. And then you see how H is going to kind of draw itself. So we have a point here. This is going to be N, and here is like a second radius. And finally, we have point H over here. So again, remember, these are both 90s. And do they give us some stats here? They tell us the radius of the circle is 168. We got 2 radiuses. And let's change up our colors. And what else do we have? The perimeter of quadrilateral, there it is. So we have G, M, H, N, so we have a 4-sided object, is 3856. So think about that. These all have to be symmetrical. This is a tangent, this is a tangent, those are radiuses, this is going to be a symmetrical object. So we know that our total, if we kind of just type this into our calculator, our total of 3856, we subtract our 2 radiuses, minus 168, minus 168. So I'll kind of write this down. 3856 minus 168 minus 168. I'm going to divide this by 2. That's going to be those 2 kind of missing sides here. That's going to be 170 or 1760 and 1760. Finally, they say, what is the distance between G and H, our center, to that point out there? Let's try to draw that line. And again, try to recognize it. We have right triangles. I swear we always do. This is our right angle right here. This is one leg. This is our other leg. This is going to be our hypotenuse here, right? 1760, 168. What's cool about this one is I could do Pythagorean's theorem, right? I could do 168 squared plus 1760 squared and do the square root of that. but look at my answer choices. There's only one answer choice that is longer than both of my legs. That's going to be D here. Again, not too bad. That's kind of our circle overview right there.